Assalamu alaikum dear students. Today I am going to demonstrate the experiment of Tripoli 4604. So today our experiment name is determination of unknown resistance by using the DC bridge. So here is the apparature. We need some component for this experiment. So here is the breadboard, resistor 10 ohm, 100 ohm, 330 ohm, 470 and 560 ohm. There is a potentiometer. So this value is 10k. So this is the actually potentiometer. So its value is 10k. So actually this is a variable resistor. So actually it can vary the resistor value. So that's why it's called the potentiometer. But in the normal resistor it's have a 2 leg, but in the potentiometer it's have a 3 leg. So you can use this one, that's 2-1 or that's 2-1. So both are the same thing actually. So its value is 10k. It means that you can vary the resistance value from 0 to 10k. So that's why it's rated the 10k value. So this is called the potentiometer. And here we need a galvanometer. So this is the galvanometer. So here's the plus and here's the minus. You can see there is a black knob over there and there are 2 red knobs. So this is the input and that's to the output. So if your range is too high, then you have to use this one, and when your range is medium or lower medium range, then you have to use this one, and this one is the common. Okay, so this galvanometer shows the positive deflection or the negative deflection. Okay, and this is the multimeter. So you already know how to operate a multimeter. So now go through the circuit diagram. So you can see there is a circuit diagram over there. So its value have already written in there, 10k, 100k, and this is Rx and this is R3. R3 means this one is actually our potentiometer, which we have to vary, and this is the Rx. So we have to find this value Rx. I mean, from this circuit, the Rs is actually the unknown resistance, and this one, and this one, that's 3 resistance are the known resistance, but Rs is unknown resistance. So by the bridge formation, we can calculate the Rs by using the value of R1, R2 and R3. So here you can see there's a plus 5 volt over there, which is connected to the point A and point C. Now we have to implement this circuit in our breadboard. For the better understand, I have already constructed a circuit according to the circuit diagram. So let's go to this circuit. So this is the circuit which I have already constructed for you. You can see there's a blue wire. So this is the plus 5 volt is connected with the circuit, and this one is the ground. I mean, it shows the negative end of your circuit diagram. So this one is connected to the ground, and this resistance value is 10 ohm, and the 100 ohm is this one, and the Rx, this one is the Rx, and this resistor is the Rx. This value the value of Rx is unknown, and this is the R3, and this is the potentiometer which I have already connected. So this is the potentiometer. So this is the R3, and there is a galvanometer over there, which one is connected to the B and D node. So this one is the galvanometer. It's connected with B and D node. Okay. So now we have to on our circuit. So our circuit is now on. through the positive side. I mean, it shows the positive deflection. We need the null deflection. Okay, so now how can we do that? We can do that by decreasing or increasing this resistor value. So I'm changing it. See, as you can see, the value is changes, and according to the changing value, the deflection is also changes. Almost zero. It's almost zero. Now it's almost zero. You see, it's almost zero. Now we have to measure resistance value of this potentiometer, and we already know the R1, R2, and this one is the R3. Which one is potentiometer? If you can measure the resistance of this potentiometer, then we get thus three resistance, and this one is the unknown. So by using this formula, or this formula, both are the same thing. By using this formula, we can measure the Rx. Now we have to measure the resistance of the potentiometer. So for that, we have to pull it out over there, and we have to switch off the circuit. Now we can measure the resistance of the potentiometer. See, in the multimeter, there is a ohm range, so it shows the resistance value. Now we measure the resistance of potentiometer. So it shows 8.76K. So remind it, it's very tough to get the accurate value because the potentiometer is so sensitive. So it actually doesn't show the accurate value all the time. So that's why you may have some error in your data. So this is our value. So this is the R1, this is the R2, and this is the R3 value. So by using this formula, we get the value of Rx is 898.67 ohm. Now we have to measure the unknown resistance value. So this is the calculated value, and now we are going to measure this value practically. So it shows 0.970 kilo ohm. So 0.971 kilo ohm, 971 ohm. So it means 971 ohm. So our practical value is 971 ohm, and our calculated value is 898.67 ohm. So the difference is 72.33 ohm. So this is actually our experimental error, which value is 72.33 ohm. So this is the end of our task number 1, and you have to do the second observation and the third observation according to the same procedure. So this is the end of our task number 1.